solving inequalities. The first example is, I've got two different problems over there, A and B. Solve and graph the two inequalities. You solve inequalities just like you would solve equations. You got to get x by itself. And then we graph. Graphing in one variable, we graph it on a number line. So the first one, the original problem is 3x minus 12 is less than 3. Solve that just like you would an equation by adding 12 to both sides. You end up with 3x is less than 15. Then divide both sides by 3. X is less than 5. When you graph these, you can either have an open circle or a closed circle. How would you end up with a closed circle?
It's greater than or equal to.
Right. If there's an equal to sign with it, like there is in the next problem, you end up with a closed, because that's showing that that number is included. That's part of your solution set. In this case, 5 is not part of my solution set. So I put an open circle around the 5, and I shade everything to the left. Does everybody remember the shading part on a number line?
Does the arrow matter? I can't remember. Is it? Does
The
the arrow?
direction.
No, like the shading of the arrow. Does it matter if it's filled in or not?
Hey, I don't care how you shade this. I mean, if you want to shade the line up here, I just drew a line representing every number to the left. So if you make it clear you representing the numbers to the left of 5, then you're fine. The easy way to remember which direction to shade in, if the variable comes first, then you always shade in the direction of the inequality. Since we're pointing to the left, I shade to the left. That's only if the variable comes first. So if your solution, you end up with a variable on the other side, you want to rewrite it. You don't have to, but if you want to rewrite it for graphing purposes, you can do that. And there's an example after this one that I rewrote it, but again, you don't have to do that. Part B, first step, you have to simplify both sides. Over here, this was already simplified, so we just went to solving. Here, I'm going to distribute the 5 to get 10 minus 5x. Combine like terms, 6 plus 10 is 16. Both sides are now simplified. Both sides are simplified, so then you just go to solving it like we have been. So I'm going to subtract 16 from both sides. You end up, at this point, negative 5x is less than or equal to 25. Now, some of you may remember when you get a negative coefficient, when you divide by a negative, what must you do to the inequality?
Change the sign.
Change it or flip it. The way I've always taught it is once you get to this step, if I have a negative coefficient with a variable, at this step I just go ahead and change all signs. So from here to here I changed this from negative to positive, changed this from less than to greater than, changed this from positive 25 to negative 25. Using that method, you won't forget, or you don't have to worry about remembering to change the inequality. But if you're okay with dividing and then changing the inequality, you're good. Okay, with this method, you don't have to worry about remembering that. Then just divide by 5. X is greater than or equal to negative 5. Since there's an equal to sign there, it's a closed circle because we're including negative 5. And greater than everything to the right. So every number to the right of negative 5 would be a solution to this inequality. The direction you shade in is the most important part of your answer on the graph, because if I shaded to the left, you got everything wrong, right? Because you gave me all the numbers that didn't work in the inequality. I want the numbers that do work in the inequality, and everything to the right works. Nothing to the left works. Okay? Next, solve and graph. So these are very similar. We actually got a solution in the first example. Here you're either going to get no solution or infinitely many solutions. So notice how I did my graph down here a little bit different. I actually shaded this line. The other two I just went up and drew a line. Either way is fine. So for the first one, distribute the 2. 2x minus 3 is greater than 2x minus 10. And which side, if you have a variable on both sides of an equation or inequality, which side do you want that variable on?
I mean,
The right, the left?
Left.
What did we talk about when we were solving equations? You want on the side with the greatest coefficient, right?
yeah.
But you don't have a greater coefficient. You have 2 on both sides, so it doesn't matter. So when I subtract 2x, what happens to the x's? They're gone. They cancel each other out. So what am I left with? Negative 3 is greater than negative 10. So if the variable cancels itself out, you're either going to get no solution or many solution. You can't get a solution if there's no variable. All right? So once you get to this point, you ask yourself, is negative 3 greater than negative 10? Is that true or false?
True.
That's true. Negative 3 will always be greater than negative 10. If it's a true statement, your answer is infinitely many solutions. Or you can just write many solutions. And to represent that graphically, just draw a number line, put 0, and shade the entire number line. All right, so in this problem, any number I picked would work, would give me a true statement if I plugged it back into the original. All right, next one. Simplify the right-hand side. So I distribute the 7. Is 7x minus 28. Again, subtract 7x from both sides. Your variables cancel out. You're left with 6 is less than negative 28. Is that true or false?
No, it's
False.
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 False. That's a false statement. 6 will never be less than negative 28. So your answer is no solution. There's no number on the number line that you could plug in for x to get this to be a true statement. All right, to represent it graphically, if you want, you could just not draw anything, but you could also draw a blank number line if you want. Okay? Any questions on those?